Mom, I can't open the lid. It is too tight.
Try putting the lid of the bottle in hot water for a few minutes first.
Do you know why Tim's mum suggested putting the lid of the bottle in hot water? From your daily experience, you may notice that a tightly screwed lid can be opened more easily after putting it in hot water for a while. This is because the lid expands more than the bottle and loosens when heated. The volume of most substances increases when heated and decreases when cooled. These phenomena are known as thermal expansion and contraction. Let us look at the thermal expansion and contraction of solids, liquids and gases in the following experiments.
Your teacher will show you a metal ball and ring set. Can the metal ball pass through the ring? The metal ball can pass through the ring. Heat the metal ball with a Bunsen flame for a few minutes. The metal ball cannot pass through the ring this time. Allow the metal ball to cool down. Try to pass it through the ring again. The metal ball can pass through the ring. What can you conclude from the results of this experiment? The metal ball expands when it is heated. The hot metal contracts when it is cooled.
Now, we are going to explore the thermal expansion and contraction of a liquid. Fill a boiling tube with colored water. Invert and fit a 1 cubic centimeter pipette with a stopper to the boiling tube. Adjust the position of the water level, so that it is at the lower end of the pipette. Put the boiling tube in a beaker of water at room temperature. Heat the beaker with a Bunsen flame until the water level rises to the upper end of the pipette. Turn off the Bunsen burner. When the water level is steady, measure the water temperature and the position of the water level. Allow the water to cool down slowly. Record the water temperature and the position of the water level at intervals of 2 degrees Celsius. Repeat the steps until the water level reaches the lower end of the pipette. The table shows the results. From the results, we know that the length of the water column increases with the water temperature. Now, we are going to explore the thermal expansion and contraction of a gas. Introduce a droplet of colored water into a 1 cubic centimeter pipette with a stopper as a marker. Fit the pipette to a boiling tube. Adjust the position of the marker, so that it is at the lower end of the pipette. Put the boiling tube in a beaker of water at room temperature. Add hot water of about 60 to 70 degrees Celsius into the beaker until the marker rises to the upper end of the pipette. Note that the hot water should be added a little at a time. And we need to stir the hot water with a glass rod. When the position of the marker is steady, measure the water temperature and position of the marker. Allow the water to cool down slowly. Measure the water temperature and position of the marker at intervals of 1 degree Celsius. Repeat the steps until the marker reaches the lower end of the pipette. The table shows the results. From the results, we know that air expands when it is heated. Air contracts when it is cooled down. From the results in this experiment, we know that gas shows a greater degree of thermal expansion and contraction than liquid. From the experiments, we can see that most substances expand when heated, and contract when cooled. However, the degree of thermal expansion and contraction of different substances may be different. In general, gases expand and contract the most whilst solids expand and contract the least.